In number 3, we've got a triangle, but we don't know for sure if it's a right triangle. So what we're going to do is try to use the Pythagorean theorem to prove that it is a right triangle. And if the Pythagorean theorem doesn't work, if one side is larger than the other, we'll know that it's not a right triangle. For example, if this side, the a squared plus b squared side, ends up being larger, that means the triangle is acute. If the c squared side is the larger side, then it's an obtuse triangle. If they balance like they normally would with Pythagorean theorem, if they really are equal, then it's a right triangle. So let's see what happens when we plug in these values. We've got to look for the largest side, which is 52, so that we can identify that as our C value. Okay, so we're going to plug that in here for 52 and call that 52 squared. And again, I'm writing this equal sign down, but it's really kind of a question mark as to whether or not it really is going to be equal. So now the other two sides, 20 and 48, will be the A and the B. So I'll put 20 here and square it, and then 48 here and square it. And those could have been flipped around. It could have been 48 squared plus 20 squared. It doesn't really matter. We're going to add those two values together. So now it's just a matter of doing some work to simplify that. So when I plug 20 squared into my calculator, I get 400. So we'll write that down underneath. I'm sure you don't have 48 squared memorized. I don't, but if I plug it in my calculator, I get 2304. And 52 squared gets me 2704. Okay, so now let's add the left-hand side. We had 400 plus the 2304 will give us 2704, and the right-hand side was also 2704, which really means that this Pythagorean theorem was actually true, and if it's actually true, then this must be a right triangle, and across from the hypotenuse would be where that right angle is located.